So we got this section in the chapter called navigation, and we can extensively use the Pythagorean theorem to help us solve navigation problems. Now, what I mean by navigation is traveling along the north-south line and the east-west line, using that to help us find locations where we are. So let's say we want to know where that pink dot is. Well, if we know the distance from the center along the north-south line, so this distance here, and we know that distance there, we have enough information to figure out what that dot is. Okay, because I can go ahead and make a triangle, right? So this distance is the exact same thing as the distance that's on the line. And, oops, didn't want to do that. And so, yeah, you can see that this is a right angle here. And we have ourselves a resulting triangle. So we can use the Pythagorean theorem. And let's go ahead and do an example where we use it. There we go. Alright, so we have again the north-south line and the east-west line. Suppose we start at that center there. And we move 1, 2, 3, 4, 5, 6, 7 units to the right and 8 units down. Okay. Even though it's going down, it is negative, but let's, yeah, it's a distance, so let's keep it positive. Anyways, this is a right angle here, so let's just go ahead and I want to find out what this distance is there. I want to find out this distance. Okay, so use the Pythagorean theorem. That's it. So we have ourselves, that's our question mark. We don't know what that is, our x. So let's call it, let's go. So we got question mark squared equals 8 squared plus 7 squared. And we get 64 plus 49, which, what does that turn out to be? 113 equals, oopsies, didn't mean to do that, 113. And then you take the square root of both sides. So our question mark is the square root of 113, and then type that in your calculator and you get yourself your decimal approximation. So that's the gist of most of the problems in this section. Okay, so I'm going to do also, as another example, one of the book problems. Let's go ahead and work on number 4, where they talk about Captain William Hawke. He left his hat on Treasure Island. He sails 18 kilometers northeast, so I already drew that. So he starts here at this center, and he goes 18 kilometers northeast right there. Okay? And then he pretty much changes direction, and then he starts going 11 kilometers southeast. So that's at that turn there. So from northeast to southeast, that does turn out to be a right angle. Okay? And then after traveling to this point here, he realizes his hat, he left his hat. So he sends his bird to fly straight back to that distance. So it takes this distance here to so he can fetch his hat. Okay, the question is, what's that distance? The idea here is always draw a picture so you can understand what's going on. Now, once you know the picture, it's not that hard. It's just an exercise in algebra. Just use the Pythagorean theorem. So let's do it. We got 11 squared plus 18 squared equals parrot squared, well, x squared. Anyways, so we got 121 plus, I believe that's 324 equals x squared, and then we get 445, right? Yep, 445 equals x squared, and then it turns should be somewhere between 20, 21. Yeah, so let me do it real quick. Take the square root of both sides now, right? So pretty much we take the square root of both sides, and we get x equals, yep, square root of 445, which is 21.09. So let's just go ahead and do 21.1. So he traveled 21.1 kilometers. Man, that parrot flew a long way. And then he had to fly back. So anyways, that's another quick example of how to do these problems.